In this lesson, we are going to learn how to describe events as subsets of a sample space. We will be using Venn diagrams to help describe these events. Let's first get familiar with some terminology with probability. A universal set is the set of all elements. So here in just a moment, we are going to work with a number dice. It's actually a 20-sided die, and this die is usually referred to as a D20. So our universal set will be the numbers 1 through 20 here in just a moment when we work on our examples. Mutually exclusive means that two or more sets that have nothing in common. So you could talk about the set of numbers less than 5 and the set of numbers greater than 7. Those would be mutually exclusive sets because they will not have values in common or elements in common. The complement in probability, that means that it is not in the subset. So a complement to maybe subset of even numbers, the complement to that would be odd numbers. So the numbers are the elements that are not in the subset. An empty set, we use the symbol, a 0 with a line through it, means there's no elements in the set. So we could look at maybe the subsets of even and odd, and if we wanted to have the intersection of those, which we'll be talking about here also, if we wanted the intersection of an even and odd subset, well, there will be no elements in those sets because an even and odd subset, they are mutually exclusive. They have nothing in common. So their intersection, there would be no values that they share in common. An intersection, we actually use the symbol, it's an upside down U. I think about it as the word and has the letter N, or even intersection has the letter N, so it looks like a lot, actually like an N. So when we're talking about an intersection, we want intersecting of those two subsets. So it's what subset have in common. What the subsets have in common. So we'll look at an example of that here in just a moment. The union, when we use the word or, that symbol will be a U, just like union. And that is when we're talking about all of the elements in the subsets. So all the elements in the subsets. So let's look at some examples to see how this terminology relates to our probability. So we're just going to be looking at subsets today of our sample space. Remember, our sample space is this D20. So the following examples, the universal set is a D20. And we're going to have these subsets, and we've already named them based on what the subset is. So we can draw a Venn diagram in order to describe these events. So let's start. Venn diagrams typically have a rectangular box around them. So this rectangular box actually describes the whole universal set. Okay, for the whole universal set. So in that box is the whole 1 through 20. But if we wanted to show the subset of evens, So that would be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And of course, we would stop there because our universal set is only up to 20. So this is the subset of evens, which is E. And also, if we want to show the subset of odds, because they are mutually exclusive, they do not share anything in common, our subsets would not overlap or touch in any way. So the odd values, starting with 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So this is the subset, as we described here, G, for that one. So we could then list what elements are in this subset E. We can list that as a set of numbers, or even this subset G. We could also list that. We could also use this to talk about which elements are in the complement of E, or even the complement of G. Let's go ahead and look at our next Venn diagram, number 2. This time we're going to have a Venn diagram of the numbers less than 7 and their complement. So again, this whole box is our universal set. So numbers less than 7. So 1, 2, 3, 4, 5, and 6 are all the numbers less than 7. We will not include 7. So this is the subset F. If we want to talk about their complement, F with the little c is how you denote the complement. Use the subscript like an exponent and put the c. So all of the values outside of this subset would be the complement. So you could actually shade to show F complement would be all of these values out in this portion of the universal set. So if we were asked to list the elements in F, which is the numbers less than 7, it would be the set of numbers 1, 2, 3, 4, 5, and 6. But if we wanted the F complement, it would be all the other numbers. So starting at 7, so 7, 8, 9, 10, 11, 12, 13, and it keeps going, 14, 15, 16, 17, 18, 19, all the way to 20, and stopping since that is the universal set is only 1 through 20. So our final example here, number 3, we're going to have a Venn diagram, this time showing the factors of 10 and numbers less than 7. So again, this whole box represents the universal set. Factors of 10, well, let's go ahead and list those first. We've got 1 times 10, 2 times 5, and those are all of our factors of 10. Because we also want to include the numbers less than 7, we will have some overlap because 1, 2, and 5 are all 3 less than 7. So this first subset we're going to call the factors of 10 are H. So this subset is H. And the ones less than 7 we called F. So here in the overlap, 1, 2, and 5, we would include in both of those subsets. 10 is only in this subset of factors of 10. Numbers less than 7, we have more than just 1, 2, and 5. 1, 2, we'll have to include 3, 4, we already have 5, and then of course 6. So this would be the Venn diagram that shows these subsets. So when we talked about the intersection, those are the subsets, what the subsets have in common. So this commonality here between the two subsets, set H, the intersection with set F is the set of elements 1, 2, and 5. We list these least to greatest and never repeat any value. So if it just so happened that a 5 showed up again, we would not repeat that in our Venn diagram or in our set of numbers. So the union, that symbol is a U. So the union of set H with set F, that will be all of the elements that they have in common, not just the intersection. It's uniting all of the elements. So we start first with 1, 2, 3, 4, 5, and 6, because least to greatest, we would definitely have all of those values that are less than 7. But then we also have to have this 10. Because if we're uniting, we're union all elements into subsets, we've got to include all of them listed in both H and F.